So I can see that many of you haven't started it, and this is great because we're going to be starting from the very beginning. Now, this funky looking gentleman over here, his name is Pythagoras of Samos. Okay, how many of you guys have heard of Pythagoras? Let me know in the chat. You can go like me, ma'am, or nah, I don't like him. Mateo's like, I'm low-key scared, don't be. Oh, of course, we've all heard of Pythagoras of Samos. He's quite the famous dude. He's the one who told us that something about a right angle triangle can be done something. Michael's like, never heard of him. Don't know that dude. Well, I will tell you something. When I saw this picture, I had to take this picture because I had to use this picture because his beard game is so on fleek. Love it. It is. Love it.
And overgrowth.
I mean, and like and he was busy there with the curling iron in the middle of the I feel it. I know he's saying, Mateo, don't you think? I think, yeah, you know what? His beard game is on fleek. Now, Pythagoras of Samos was actually a philosopher and a bit of a mathematician. And a lot of the stuff that he came up with wasn't 100% done by him. And this is something that a lot of people don't know, that Pythagoras himself may or may not have come up with the Pythagorean theorem. What he did, though, was he was a philosopher who had quite a lot of followers. And a lot of his followers believed in the mathematical ideas, like the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 meant a lot to people who followed Pythagoras of Samos. So like the number 1 is like a very significant number because it symbolizes unity. The number 3 was also very important because it just showed the 3 stages of things, like there's always a beginning, a middle, and an end. And the number 4 is because we have 4 seasons. So the Pythagoreans, who were the people who actually came up with Pythagoras' this theorem, they believed in the beauty of numbers. Now, one thing that they stumbled across accidentally was, I know he was the OG with tons of followers. That's it, teacher. And I was like, literally, guys, if Instagram was a thing back then, he'd be Selena Gomez. You understand what I mean? You get that reference right now, right? Yes, so they didn't believe, however, in irrational numbers, but that didn't quite help because when they discovered Pythagoras, we know that the formula for Pythagoras is if we have a side, BC, we know that the square of the other 2 sides added together will give us the square of the longer side. So the base and the altitude squared will give us the hypotenuse squared. And Ndumuluko, you are on the money. Okay. Seleza says, can we say opposite instead of altitude? Absolutely. We are not going to be learning about the altitude and the base. The only reason I've put this example here is because this is the original one that was theorized in the beginning. All right. So I know that we've all seen Pythagoras. Okay. Michael, it's actually quite cool. Imagine you no longer exist, but you had a lot of cool followers and then they just name things after you. I want that. I want like the theorem of Teacher Coco to come out one day, and then, you know, I won't be here, but people will still be talking about it, even though I didn't do it. That sounds pretty cool to me. All right. So we're going to be using Pythagoras' theorem to be solving for these 6 examples over here. They are very basic, and you can tell that we're just looking for the hypotenuse in 4 of them, and in 2 of them, we're looking for a side. All right. I'm sure everyone knows how to do these, guys. I'm going to give everybody about 6-7 minutes to get through these. And when you're done, I want you guys to pop the fire emoji in the chat. All right. Okay. You guys have got 5 minutes. Go for it. Remember, guys, no answers. All you need to do is pop the fire emoji when you've answered all 6 questions. Mateo's like, ma'am, how do you do this again? Oh my goodness. All right, remember that the smaller side squared. So we're going to take the small side, which is 9, and we're going to square it, plus this long side, which is 12. and we're going to square it, and that's going to give us x, the side squared. And remember, we need to state why we're doing this. This is Pythagoras' theorem, right? Now, 9 squared is going to give me 81 plus 12 squared, which is 144, is equal to x squared. Add these two numbers together. That's going to give me 225. Oof, I'm writing that wrong completely. 225 is equal to x squared. Now, I don't want x squared, I want x. So in order to get rid of the x squared, I have to take the square root of both sides. And therefore, x will be equal to the square root of 225, which is 15. And Nomaza, hi, I have a feeling you just joined us. We are using Pythagoras to solve for these. Okay. Everyone has got 4 minutes left. Okay. Oh, excuse me. Don't look, it's already done. And you guys are like falling way behind. Okay, I think it might be easier for us if we wrote it the other way around. X squared is equal to 9 squared plus 12 squared. Okay, and this is equal to Pythag. Okay. Oh, this is because of Pythag. And then we can solve for x from here. All right, try the same with number 2, 3, 4, 5, and 6, and then pop the fire emoji in the chat for me when you're done. And remember, guys, the two shorter sides, this side plus this side, is equal to the longest side. So if you look at number 4 over here, they've given me the longest side. So think about what that's going to do to my equation. Okay, maybe let me write the equation over here. Okay, the opposite squared plus the adjacent squared, because that's the one we're going to be learning about, is equal to the hypotenuse squared. All right. Or the other way around. Hypotenuse squared is equal to opposite squared plus adjacent squared. All right, I've only got one fire emoji so far. You guys have 2 minutes left. You let me know how you're doing. Yes, Funzo. Useleta says, ma'am, where did you get 225? Useleta, 81 plus 144 is 225. Thanks, teacher Knowles. That's it. Oh, the Tepile is done as well. Awesome stuff. That's it, Funzo. We're going to get there. We just need this part first, okay? Because this part makes a huge, it makes up a huge part of the trigonometry that's coming. Oh, Michael. Thanks, Kivoratile. 1 minute left, guys. Funzo's done as well. And Nombulelo, excellent stuff, guys. Technically, you've heard of it. Okay, now you physically have to try the examples now because you've only heard of it technically. Now you physically have to do it. Yeah. Thank you, Mlando. Dan. Nolwazi's like, just joined, so I'm lost. Nolwazi, we're literally just using Pythagoras to answer these questions. All right, that's our time up. Okay, we're going to look at number 2 quickly, and I'm going to do it over here on the side. Yes, Kehoratili says, if you can't find the square root, do we leave the answer as a square root? Absolutely, all the time. Okay, all the time. We keep it there. All right, so let's look at number 2 quickly. I can see that I've got my 2 shorter sides, And my two shorter sides squared are going to give me the side squared. So I can say x squared is going to equal to 10 squared plus 24 squared. If you wrote it the other way around, if you wrote 10 squared plus 24 squared is equal to x squared, that's correct as well. There's nothing wrong with that at all. Okay, and my reason for this is always Pythag. Okay, we must give this reason, guys. This is a mark. This is a mark. We need that Pythag in there, okay, because it shows us where did we get this funky little thing that we're using here. We must do this. Okay, so then we're going to find that x squared is equal to 100 plus, I have no idea what the 24 squared is. I'm not going to lie. 24 squared is 576. 576. And then x squared will be equal to 676. And the square root of 676, remember, we don't want x squared, we want x. So we're going to take the square root of both sides. Therefore, x is equal to 26. Well done, Zudine. That's it. That's exactly what I was looking for. Excellent. All right, let's look at this next one over here. I think this one I'll be able to do in my head. It's not going to be too difficult for me. Number 3, they've given me my two shorter sides. So again, x squared is equal to 3 squared plus 7 squared. And my reason for this is Pythag. Okay, they keep changing this convention. Sometimes they want you to write Pythagoras. Sometimes they say you can write Pythag. It's so confusing, teacher Nels, I'll tell you. Mathematicians can't make up their minds. I don't know. Okay, so now I've got x squared is equal to 3 squared is 9, plus 7 squared is 49. Therefore, x squared is going to equal to 9 plus 49 is 58. Now, I know that 58 is not a perfect square. So I'm going to leave my answer as x is equal to the square root of 58. We're not going to go any further with this. We're going to leave it right here. Okay, can somebody tell me, and I know your teachers have probably taught you this as well, why is it that when I take the square root, why do I not take the plus and the minus of my square root? Does anybody know why? Because I can bet you somewhere when you guys were doing like equations or something, your teacher was like, if you square root, there must be a plus or a minus. Does anybody know why I haven't said plus or a minus? Yes, Bashe, that's it. Anybody? Who knows? Teacher Nels? Do you know?
Why?
Why I didn't take the plus and the minus of my square root?
Oh, because, is it because they're in the first quadrant or what? Is it?
Ooh, it has nothing to do with quadrants. Think about, what are we actually calculating for?
Oh, this time around, we're calculating for the longest. It's always positive, the hypotenuse side.
Yes, so we can't have, we're calculating for the length of a side. And I can't have a minus 26 for a length of a side. Okay, because it's a length, we don't have to take the minus of it. We can just take just the negative of it. Okay, Teacher Nels, you're doing a great job. Keep it up. I feel like I'm teaching Teacher Nels maths. Okay, I hope you guys understand why we don't have to take the plus and the minus of that. We only need the positive because you can never get a negative length. Okay, and we are calculating for the length of these sides. Okay, let's have a look at number 4. Yes, Shaden.
Ma'am, I'm so sorry to disturb you.
No worries.
My answer for the first one was actually wrong. I got x equals to 15. What am I missing, ma'am? What am I missing?
No,
because
I got it correct. Here it is, here. The one we were doing.
No, not that one, ma'am. Sorry, the second one. Sorry.
Okay, this one over here.
Yes, I said because I said 10 squared plus 24 squared equals to x squared, and then I said 100 plus 576 equals to x squared, and then 100 and 576 equals to 676, and then I square rooted that. only.
And you got 15.
Yes.
Oh, I don't think that should happen. Try and square root it again.
Okay.
Square root of 676.
Oh, shit. Oh, I got 26. I think I made a mistake. I'm so sorry.
I think you just calculated. You may have taken the number from your first answer and then just accidentally popped it into your.
Oh,
Yeah.
okay. Thank you so much. I'm sorry.
No worries. No worries. Okay. All right. Let's have a look at number 4. Now have a look, guys. In number 4, they've given us one of the short sides and one of the long sides. So they've already given us like our x squared in the other question. Yes, Funzo?
Hi, ma'am.
Hello, my sweetie. What's up?
I was asking if I could answer number 4.
Yes, absolutely. Let's go for it.
So I said 10 squared is equals to x squared plus 6 squared, and the reason is Pythagoras.
Oh my goodness, you're doing so great already. Like from the jump, you've got this. Okay, what comes next?
Then I said 100 is equal to x squared plus 36.
Okay, 100 is equal to x squared plus 36. Excellent. Then what can we do?
Then I said 100 minus 36 is equals to x squared.
Good. We're going to take the 36 over and we're going to go 100 minus 36 is equal to x squared.
Then I wrote 64 is equals to x squared.
That's it. And then?
Then I square rooted them. I square rooted them.
Good. And we square root both sides and therefore?
Therefore, x is equals to 8.
Oh, beautiful. Amazing. Just, wow, excellent. Okay. Beautiful, beautiful stuff. All right. I think you did that so beautifully, Funzo. I didn't even have to show you how to do anything. Okay, because I thought it was going to trick you, but it doesn't look like it tricked anyone because now we know that we've got the hypotenuse squared. We just need to work out for the other side. Samkelo, do you want to do number 5 with me, my sweetie? Let's take it slowly because I can see you're a little bit lost, but let's take this one slowly. Do you want to unmute for me and we can have a bit of a conversation? Oh no. Okay, Samkelo's not unmuting. Nolwazi, do you want to unmute for me?
Yes, how are you?
I'm good, thank you. How are you?
I got square root of 136. I don't know where did I go wrong.
Okay, so Nolwazi, have a look here. So remember in all these other questions that we had up top here, I took the 2 short sides. So I got short side plus short side equals long side. Yes?
Yes, ma'am.
So if we do the same with this one over here for number 4, I'm going to have short side plus short side equals long side. Do you agree with me?
Yes, ma'am.
Okay, good. So one of my short sides is x squared. So I have x squared plus my other short side is 6 squared. Are you still with me?
Yes, ma'am.
Is equal to, what's my long side?
It's 10 squared.
10. Good. Now I'm solving for x. You agree with me?
Yes, ma'am.
So I can take 6 squared over to that side. And if it's positive on this side, what's going to happen when I move it to that side? It's going to become?
Negative.
Good. So I'm going to have x squared is equal to 10 squared minus 6 squared. Are we still together?
Why did ma'am take it from the positive 6 squared to negative 6 squared? That's where I'm lost.
Okay, because it went over our equal sign. Remember what happens when things go over an equal sign? What happens to the sign?
They change the sign. It becomes negative if it was positive.
Exactly. So it was positive on this side. When I took it over to the other side, it became negative. Yes, ma'am?
Yeah.
Are you still with me?
Yes, ma'am. I'm so confused because all along we want transposing as in like changing it from this side to the other side. So why are we changing it on number 4?
Because I want x on its own. I'm actually solving for x. Look over here, up top here. X was my long side. Do you understand what I mean? X was my long side. So there was no need for me to transpose.
Oh, so because x is the shorter side, you need to
now in this one, x is the shorter side. So we must transpose to get x on its own.
Oh, okay, ma'am. Thank you.
Okay. So if you look over here, Nolwazi, if I were to do this one, I've got a short side squared plus a short side equals x squared. So I would have 10 squared plus 24 squared is equal to x squared. Is there any need for me to transpose anything here?
No, ma'am.
No, because my x is already on its own. Do you see that?
Yes, ma'am.
So the problem with this question that we're doing now is that I've got x squared plus 6 squared is equal to 10 squared. Now x isn't sitting on its own. You see that? X is sitting with 6 squared. So I need to move everything that doesn't have an x over
to the other side.
You see what's happened there?
Yes, ma'am.
Excellent. All right. So I'm going to then get x squared is equal to 10 squared is how much?
It's 100.
Good. 100 minus 6 squared is?
Minus 36.
Good. 36. So I'm going to get x squared is equal to 100 minus 36 will give me 64. And then I'm going to take the square root of both my sides. All right.
Yes, ma'am.
Therefore, x is going to equal to, what is the square root of 64?
It's 8.
And that's it. Do you see how we got 8 over here?
Yes, ma'am, I see.
Excellent. All right. Are we still confused? Are we okay? Are we happy? Still kind of confused? Okay. Shaden's going to help us do the next example, and then you'll see as we're going how we're doing it. Okay. All right. Okay. All right. Shaden, you said you wanted to please do the next one. Are you gonna raise your hand so we can unmute you? All right, Potato, I'm gonna come to you in just a second. Shaden, okay, where am I starting with number 5? Let's have a look.
So, ma'am, I said 24 squared.
Good.
Equals to
equals
to x squared.
X squared
Plus 6 squared.
plus 6 squared. I haven't done anything different, Shaden. I've just written it in different order. Okay.
Okay, and then 24 squared equals to 576.
You forgot something very important.
I put 24 squared in the. Oh, Pythag. Oh, I wrote it down. Sorry, Pythag. Sorry.
You must say Pythag. Thank you. Where did you get this funky formula from? You must write Pythag. Okay, all right. So you're saying we wrote, what's the next line that you wrote? X squared?
And then for 24, I wrote 576.
Okay, so I need you to give me the line exactly the way you wrote it. Otherwise, it just it's a bit funky. Okay, what did you write in your next line? What did you write?
576 equals to x squared plus 36.
Okay, 576 is equal to x squared plus 36. I'm doing exactly what you're doing, just in a little bit of a reverse way. Okay.
Yes, ma'am. And
then
then
what happens next?
And in the next line, I wrote 576 minus 36 equals to x squared. Is that right?
So I'm just going to write it the other way around. X squared is equal to 576 minus 36. You and I are doing the same thing, just opposite ways. Okay.
Yes,
Okay. What comes next?
And then I square rooted. I minus that 36 by 576. And then I got the answer of 540.
So
And
x squared is equal to 500, or 540 is equal to x squared, right?
Yes, ma'am.
And then
And
we
then
square.
therefore,
Mm-hmm.
therefore 540 is it gives me a I think it's called a sixth
A
root.
third, yeah, it's called a third. Don't worry about it. So
Third.
if it doesn't give you a perfect answer, just keep it as the square root of 524. Okay.
So if it doesn't like give me like a proper answer that like a normal one, then I should just leave it as it is, like 540.
That's it. The square root. Don't forget the square root. The
Oh,
square root is important.
sorry.
It's part of
Yes.
the answer. Don't lose the square root. Okay.
Yes, ma'am.
Excellent. You did that so beautifully. Very, very well done.
Thank
Amazing.
you.
Excellent. Kotatso, do you want to do the last one with me? The last one is so easy. You want to unmute for me?
Ma'am,
Yes.
no, I want us to go back to number 5. I don't understand why is it 576 minus 36? Why is it not plus?
Because my 36 was plus on this side. And what happens when I take a plus thing over to the other side of an equal sign? It becomes
Negative.
negative. That's why we wrote negative 36 on this side.
Okay, ma'am. So for that 540, is it like that for like it's a final answer or what?
Yes. The square root, not just 540, the square root of 540. Okay.
Yes, ma'am.
Yeah, so
Okay,
you can
fine.
leave it as the square root of 530. 540.
Okay.
Okay. All right.
Yes,
But I can't let you go away. You have to do this last one for me. Okay, look at this one. I've got a short side plus a short side is equal to x squared. What am I going to write?
X squared
Good.
is equals to 1 squared plus 1 squared.
That's it. Good. And then?
And then x squared.
Ooh, she forgot to write
Oh,
Pythag.
Pythag. Sorry.
Okay, good. And then we can say x squared is equal to?
Is equals to 1. Is equals to 1 plus 1.
Yeah, 1 plus 1. That's it. 1 plus 1.
Yes.
So x squared is then equal to?
2.
2. Good. But I still need to take the square root of both sides.
Yes, ma'am.
Okay, good. So therefore, x is equal to?
X is equals to the square root of 2.
Beautiful. Mwah. Like the most beautiful thing I've heard. Okay. I must
Yes,
keep the square root because 2 is not a perfect square. So my answer is not going to be 2. It's going to be the square root of 2. Kotatso, you're a whole angel. Well done. Amazing.
Thank you, ma'am.
Amazing. Awesome, awesome stuff. All right, guys, remember, unless it's a perfect square, it's not going to give you a beautiful answer. So you need to keep it under the square root sign. So if I had written, therefore x is equal to 2, nope, wrong. Because the square root sign is still there. I can't take away the square root sign unless it's a perfect square. Shaden, do not forget the square root. Don't forget the square root. It's always there. All right. Can I get from you guys a thumbs up, thumbs down? How are we feeling about Pythagoras? In the chat, give me a thumbs up. Give me a thumbs down. How do we feel about Pythagoras? Funzo is hundreds. I'm seeing many, many thumbs up. Hi, Nomaza. How are we doing?
I'm good, ma'am.
I'm
Sorry.
Are you a bit lost? Is that why we've got our hand?
Not really.
Okay.
For trig, I heard
Yes.
that Pythagoras isn't normally as accurate.
Sometimes. And the reason for that is because that's why we keep things under square root signs. Okay. That's why we don't like take the shorter version of the angles and the such. Okay. So trig is very particular, but it works around the idea of a right angled triangle. Okay. They kind of sort of work synonymously with each other. But to an extent, yes, we could almost say that trig is more accurate, but they feed off of each other. Without Pythagoras, we wouldn't get trig.
Okay. So for the sine, cos, and tangent, I'm guessing each system, or whatchamacallit, has like its each side, right?
Yes. Yes.
Okay.
And we're going to talk about that just now. Okay. That's what we're doing. Excellent.
Thank you.
Oh, that was a thank you, ma'am. You're very welcome, Nobasa. Sorry, I think I'm glad we're getting 5 out of 6s, and Tabiso got everything right. I love that. All right. Okay, now we figure out that Pythagoras isn't the dude who came up with trigonometry, though. He's not. His people are the ones who gave us the Pythagorean theorem. Okay. Hipparchus of Nicaea is actually the dude who came up with the idea of trigonometry. This is our sine and our cos and our tan. All right, and I see Funzo asking, so many, I think she meant ma'am. So ma'am, does trigonometry only work on right-angled triangles? Yes. And you're going to get to grade 11 and they're going to say, what happens when it's not a right-angled triangle? What happens if it looks like this? My response to that is that I can always do this. I can always do this, and I can turn that into a right angle and that into a right angle. Okay. So Pythagoras and the idea of trigonometry, right angled triangles, they are not brothers, because I'm looking at somebody ask, is that his brother? I think the beard might be confusing a little bit. Edges on fleek. And with the lipstick, I mean, he's doing the things. He's doing the things. All right. Okay. So Hipparchus found out something very, very cool. Okay, we're going to say that. All right. So Hipparchus said to himself, all right, how do we figure out how long these sides are? However long the sides are going to be impacted by my hypotenuse. Okay. My hypotenuse and my adjacent side. So he decided that I'm going to take a stick and I'm going to put it up at an angle. The angle is called theta. It doesn't really matter what this angle is. We're just going to put it up at an angle. And he realized that if he puts this at an angle like that, there's a particular value for my adjacent side, and there's a particular value for my opposite side, dependent on the angle. And then he's like, okay, hold on. But now what happens when I move this little stick of mine just a teeny bit further down? If I move it over here, he noticed, okay, now what happens is, if my hypotenuse stays the same, my opposite side gets shorter and my adjacent side gets a little bit longer. Okay, but my angle's gotten smaller. Okay, and now he's like, okay, let me make my angle just a little bit smaller. So make my hypotenuse stick just a little bit smaller. My opposite side gets even smaller, and my adjacent side gets even longer. Okay, and he realized that the angle over here is determined by how long this side is in comparison to that side when we move our hypotenuse. Okay, so the angle has something to do with the other two sides as they move in relation to the hypotenuse. And that's where he came up with the idea of sine, cos, and tan. And now, if you haven't done trigonometry before, you're going to have to learn these new terms. Okay, this little thing over here in the middle is actually a Greek symbol. We call this theta. Okay, this is called theta. And theta basically just means some angle. Some angle. We're going to choose what this angle is. We will choose what the angle is. So theta is just in place of the angle, much like in trigonometry, not in trigonometry, in algebra, when we have x standing in place of a number, we use theta in place of an angle. All right. Now, the way we're going to remember all of these adjacent, hypotenuse, whatever, okay, is it on my side, teacher Nels? Can you hear me?
Yeah, I can hear you like clearly.
Okay, because some girls like, ma'am, network is not make sure, and I don't know if it's on my side
Maybe
or
on his side.
yeah, I
Let me
hope.
ask.
Okay, because mine is fine. All right. So if I have my angle down here, guys, the side right over here, right next door, the angle next door is called the adjacent. Like your neighbor right next door, is your adjacent neighbor. They are adjacent to you. Yes, Nomaza?
Sorry, ma'am.
Yes.
I don't see the tangent sign anywhere. We're gonna do that in a separate lesson.
We're going to do it. It's just this thing is equal to opposite over adjacent. Sorry, I don't know why it didn't. I think the picture cut it off. It was there. I don't know what's happening.
Thank you.
It is there. We're going to do all three of them. Okay. All right. So the side right next to my angle is called the adjacent, and the side that's furthest away, all the way over there, is called the opposite side. So the side opposite to my angle is called opposite, and the longest side is called the hypotenuse. Okay, so we have adjacent, and we have opposite, and we have hypotenuse. All right, now our hypotenuse, you guys will note, our hypotenuse is always opposite from our right angled triangle. So wherever my right angled triangle is, my hypotenuse will be right on the other side of that. Okay, so those are the things that we need to remember. Okay, now these things, sure, Sisa just joined us. Shaden's like, I think we learned something like this. Yes, I actually remember teacher Jen teaching you guys this stuff. I was there. I was TAing for her that day. Okay, so this side is our angle. The side right next to our angle is called the adjacent side. The side far away from our angle is called the opposite. And the longest side of our triangle is called the hypotenuse. Now, when we put all of these together, we call them sine, cos, and tan. And the easiest way for us to remember this is with a mnemonic advice, which Karen has already put in the chat for us. So, ka, toa. All right, I'm going to need some volunteers. Okay, I'm going to need some volunteers. We're going to start right here. If my angle, I'm going to name this A, B, and C. If my angle theta is over here, who can tell me what is my adjacent side? What is my adjacent side? In fact, you can give me all three of them, Namaza. Go for it. What is my adjacent side?
Wouldn't it be your hypotenuse?
Oh, no. Hypotenuse is always the longest side, right?
Okay.
So my adjacent side is
guessing
one right next door to my angle. So it would be?
So I'm guessing it would be your opposite.
It would be this one here. Okay, so it would be A, B. Have I lost you a little bit?
No, not at all, ma'am.
Okay, so my adjacent side is always the one right next to my angle, which is A, B. So this is my adjacent side. Okay, which one is my opposite side?
AC.
Ooh, AC is my longest side. Look, this
So
one is my
CB.
longest side. Yes, so it's going to be this one all the way on the other side. So CB is going to be my opposite side. Okay, and this longest side is always
going to be my hypotenuse.
That's it, my hypotenuse. Okay, let's try another one. Let's try again.
Okay.
All right. I'm going to put my angle down here. There's my theta. Which side is my adjacent side? The side next door.
CB.
That's it. Good. This one over here is going to be my adjacent side. Where is my opposite side?
AB.
That's it. All the way on the other side. This is opposite. And then this one over here will be my
hypotenuse.
AC will be my hypotenuse. Excellent. Do you see how that works?
Yes, ma'am.
Okay, excellent. We need to remember that. Okay, because our angle is always going to tell us what is in reference to it. Nomaza, you're a whole rock star. Thank you so much for always unmuting
Thank you,
your
ma'am.
chat. All right. Does anybody else want to give it a go? I want to see if somebody else can get this because I feel like this is super easy. Shaden, I'm going to give you an easy one. Okay, instead of calling it theta, I'm going to call it alpha. And I'm going to call this side D, I'm going to call this side E, and I'm going to call this side F. Okay, that's my right angle triangle. Shaden, let's go. Okay, which side is adjacent to alpha?
Is it FE, ma'am?
That's it, the one right next door. Good. This is my adjacent side. Where is my hypotenuse?
It will be FD.
That's it, my hypotenuse. Excellent. And then what is my opposite side?
DE.
That's it. Oh, you did that so beautifully. Well done. Just no, excellent. Excellent. All right. Moteo, I've got a bit of a trick question for you. All right. I'm going to name this one over here beta. It also stands for an angle. Moteo, if beta is over here, where is my adjacent side?
FE.
Here is my angle. This is my angle.
DE.
Good. It's the one right next door. So this one is adjacent. Where is my opposite side?
FE.
That's it. Opposite. Opposite. And my hypotenuse never changes, does it? Doesn't change at all. Thank you, Muteo. Excellent, excellent, beautiful. All right. I want to show you guys something very important with what we just did, this exercise we've just done with Shaden and Muteo. Have a look, guys. When I change where my angle is, my opposite and my adjacent change. Do you guys see that? When my angle is up here, my adjacent is over here. But when my angle is down here, my opposite, that becomes my opposite. Okay, so it's very important for us to look at where each of these is sitting in reference to my angle, because my adjacent and my opposite sides will continuously change. Okay, my adjacent and my opposite sides will continuously change dependent on my reference angle. Okay, now we're going to get back to that SOHCAHTOA that we just saw. I hope you guys all remember our nice mnemonic device. Sure, I don't like that word. Okay, SOHCAHTOA. Okay, now this is very important. I'm going to write down here A, B, C. And then I'm going to make my angle. This is a right angle triangle. Better not forget. Okay, I'm going to write over here. I'm going to write a theta sign. The theta sign, right? Now, so this S over here for so stands for sine. Okay. And this O over here stands for opposite. And this H stands for hypotenuse. And the way we read this is that my sine of theta is going to equal to my opposite side over my hypotenuse side. That's how we read the SOH part of my SOH, of my question, of my mnemonic, I hate that word, mnemonic device. Okay, now if I had to ask you guys, where is my opposite side to my theta angle? What is it called? What is my opposite side to my theta angle, to my angle theta? What is it called? My opposite side, guys, not my adjacent. My adjacent would be here. And you guys would be right if you're looking, if I was looking for my adjacent. Ndebo, what do you think?
Ma'am, is it BC?
Yes, it is. It's that one over there. It's this one over here. This is my opposite side. So in this over here, I'm going to write sine of theta is equal to BC, because that's my opposite side, over what is my hypotenuse, guys? What is my hypotenuse? That's it, Tabi. So my hypotenuse is AB. So we're going to write here AB. Okay. We're going to do cos and we're going to do tan very quickly because we're going to run out of time. Okay, so this next one over here, this C stands for cos of theta. So we're going to write the cosine or cos, the cosine of theta is equal to, what do you guys think this A stands for and the H stands for? Oh, I'm sorry, Mateo. A stands for adjacent, good. And H stands for hypotenuse, adjacent and hypotenuse. All right, so my cosine of theta or my cos of theta is going to be the adjacent over the hypotenuse. Now, look at where my theta angle is, guys. What is the name of my adjacent angle? The one next door. Funzo. My adjacent angle is?
It's AC.
That's it. Good. It's AC. It's this one over here, adjacent. And what's my hypotenuse angle or side?
AB.
Good. It's AB. This is my hypotenuse. Good. So I'm going to have cos or cosine of theta is equal to AC over, can you want to finish this one for me? AC over?
AC over AB.
Good, over AB. Beautiful. That's what I was looking for. Excellent. Well done. Amazing. That's exactly what I was looking for. Funzo. Mwah. Excellent. Okay, let's look at tan. Let's have a look at tan theta. Okay, Namaza, are you there?
Yes, sorry, I was just gonna ask. So katoa is just a simplified version of sin is equal to opposite over hypotenuse. And then cos is adjacent over hypotenuse, and then tangent is opposite over adjacent.
That's it. That's all.
Okay.
That's it. Okay, now you have to do this one for me. You have to do tan theta for me.
Yes.
Okay. All right. So my tan theta is equal to my opposite over my adjacent.
Over adjacent. Yes, ma'am.
Good. What is my opposite side? What is the name of my opposite side?
It is BC.
Good, because it's all the way over there. This one is my opposite side. And my adjacent side, we've already said is?
AC.
That's it. Good. So tell me if I had to write it as one side over the other, my opposite is?
Sorry, is this still for tangent?
Tan theta is equal to?
Opposite over adjacent.
Good. We've got opposite over adjacent. What is the opposite side called?
Oh, sorry. BC over AC.
That's it. BC over AC. Just excellent. Very well done. It's not that difficult, especially when you remember SOHCAHTOA. It makes it so much easier.
Yes, ma'am.
Excellent. Okay. Awesome stuff. All right. We are out of time because I'm going to have to rush. Now, I want you guys to do this exercise quickly. Okay. Have a look over here at the bottom over here. This is what I'm going to do. I'm going to keep my triangle exactly the way it is. I'm not going to help you guys cheat. You guys must do this on your own. Yeah. All right. This is theta. Here's theta over here. And beta is over here. Okay. I want you guys to do the sine, the cos, the tan of theta. And then I want you guys to do the sine, the cos, the tan of beta. Now remember, depending on where my angle is, my opposite and my adjacent is going to switch around. So make sure when we're doing sine, I'm going to go sine theta is equal to, and then my mnemonic device over here is going to remind me that it's equal to something over something. So I already know it's going to be opposite over hypotenuse. I think I'm cheating. I'm already giving you guys the answers. Now, you just need to go figure out, in relation to my angle theta, which side is my opposite side and which side is my hypotenuse side. You guys need to figure that out and then make sure you're writing this according to whichever side is which. All right, everyone, screenshot. If you can't take a screenshot, I need you to draw a very ugly triangle on your book. Just do this quickly and go theta, beta, like that, and then go A, B, C. Okay, and then quickly write that down because I'm going to leave in the next minute and a half. Okay. Oh, thank you, Shaden. I'm so glad you're enjoying it. Trig is so nice when you understand what's happening. I promise you, you're going to have the time of your life. Okay, for those of you who are seeing trig for the first time, I hope it wasn't too much of a, I don't think it's that bad. I don't actually think it's that bad. Okay, this is sine. Ah, come on. You don't like trig guy? I like trig guy. I think he's pretty cool. Opposite and hypotenuse. Yes, no, Lwazi. Hi, no, Lwazi.
Yo, ma'am, I don't think trig is. Hi, ma'am.
Hello. You don't think trig is?
I don't think trig is interesting. It's actually very hard.
Oh, it's not hard at all, my sweetie. We just need to remember the rules. I tell you that now. Okay. If we just follow the idea of the angle and the sides getting smaller and bigger and smaller and bigger on each side, you kind of understand where it's coming from. Okay. And Nolwazi, we're going to have to know this very, very well because it makes up a huge chunk of your matric paper, paper 2. I think trigonometry is like 1/3 of your matric paper. So we need to know trigonometry very well. Okay, I'm going to have to go.